Hello there, ICP students. This is Mr. Nutzel, and we are going to be going over the notes outline for Chapter 1, Section 2. It's actually Sections 2, 3, and 4. In the book, it talks about measurement, graphs, and technology. So the vocab terms, we'll go ahead and open this up so it stands up a little bit. We got our vocab terms here. One of your assignments this week is to go ahead and define those. Bill Gates' quote here says, "I have been struck again and again by how important measurement is to improving the human condition." Okay, so this unit's about measurement, and Bill Gates, pretty rich guy, but he wants his money to be put to good use, and so he measures more and more the effects his charities and stuff do. So suppose you and a friend want to make some measurements to find out whether a desk will fit through a doorway. You have no ruler, so you maybe decide to use your hands. So you sit there and you go and you measure the hand. You say 12, your friend says 13. It should fit, but when you move it, it doesn't. Why doesn't it work? Well, if I'm using my hands and my child's using his hands, we're not going to have the same size hand. And so therefore, using your hands to measure things, while it might work briefly on some things, it's not going to be very precise. So to fix that, while hands are a convenient measuring tool, they can lead to misunderstanding. So what you need is a standard. A standard is an exact quantity that people agree to use to compare measurements. So we have inches or centimeters or other things. Okay? So looking at a ball of string, we notice that the length of the string is 150. That won't make sense because what we need is a unit on there. Is that length 150 feet, 150 meters, or 150 centimeters? Those are all vastly different sizes. Okay, for a measurement to make sense, it must include both a number and a unit. There's a standardized system of measurement for almost the entire world. There's 3 countries that aren't on there, and that would be the USA, Burma, and Liberia. Those 3 countries are the only countries that have not adopted the SI measuring system or the metric system. All SI standards are universally accepted and understood by scientists throughout the world. Right here we see that we measure length, volume, mass, density, and temperature. So length is a meter, volume is a liter, abbreviated as an L, meter is abbreviated as M. Mass is measured in grams or kilograms, and that's G or kg. And then temperature is measured in Celsius. These are the SI units. Again, like we've said, there are other units that we use here in America, but those are SI units. And then there's also derived units, which are a combination of units. For example, if I'm measuring the speed of something, that's going to be length divided by time, or meters per second. If I'm measuring the force of something, that's going to be a mass times acceleration, which is a kilogram times a meter per second squared. Okay, so these are all examples of derived units. Anytime you have a divided by or a multiply, then it's going to be a derived unit. Okay. The nice thing about the metric prefixes is that you're either multiplying or dividing the same amount by 10. So whatever our base unit is, we can multiply it or divide it by 10 or a series of 10s, and you can change from one type to another. Okay? So deca means that it's a multiple of 10. So there are 10 meters in a decameter. A hectometer has 100 meters for a hectometer. And a kilometer has 1,000 meters. Deci means you have 10 decimeters in a meter. There are 100 centimeters in 1 meter. And milli is, you're dividing by 1,000, that means you have 1,000 millimeters for every 1 meter. Okay? There's this, kids have dropped over dead converting metrics, or King Henry doesn't usually drink chocolate milk. These are little mnemonic devices that help you to go from kilometer all the way over to centimeters or whatever the units is that you're changing. There's actually going to be a separate video where I walk through how to change and convert units. Okay, some practice problems. 1,000 milligrams turns into hectograms. We're going to have to go to the left quite a bit because we're on the left side of that last part. The milli, we got to go over to the hecto. So my decimal is going to move a bunch of spaces to the left. Okay, the centimeters, that is increasing because you're moving from centi to milli, so that's an increase. Kilo to milli, that's a big increase. Decimeter to decameter, that's a drop, so we're moving to the left on the scale, so my units will move to the left, the period on there. Length is the distance between 2 points. In the SI system, we use a meter. Volume is the amount of space an object takes up, and that's either a cubic meter, cubic centimeter, or a liter. And then mass, we measure the amount of matter in an object. That's kilogram and grams, sometimes milligrams, depending on how big the object is. Temperature, we measure that in degrees Celsius. Water will freeze at 0 and water will boil at 100 degrees. And then density is another derived unit. That is, the density of object is the mass divided by its volume. Okay? Couple questions. A blank is an exact quantity that people use to compare measurements. The answer to that is standard. Number 2, a kilogram is equal to 1,000 grams. So there's 1,000 grams for every 1 kilogram. The amount of space occupied by an object is called its volume. And that takes us to the end of these notes. Go through, fill out the notes outline, which you have a copy of down here, and then go ahead and you can submit that, and that is one of your assignments for the week.